must be added to x² plus 6x to make it a perfect square. Let the number to add be k. Then the expression x² plus 6x thus becomes x² plus 6x plus k. This, for it to be a perfect square, must be equivalent to x plus, say, constant a all squared. We adopted plus in the middle because the sign before the 6x is a plus. Then we will try to expand the right hand side. So we have x² plus 6x plus k to be equivalent to x² plus 2ax plus a squared when we expand the right hand side. Then we compare the coefficients. 6x can be compared with 2ax. So we can say 6 equals to 2a. This implies that a is 3 when we divide both sides by 2. K, the constant to add, can be likened to a squared. Then k must be 3 squared, as 3 is the value of a, and that is 9. So the constant to add so that x² plus 6x factors out as a perfect square is 3 squared, which is 9. We can rewrite the expression thus: x² plus 6x plus 9, or x² plus 6x plus 3 squared. And when it comes to factoring perfect squares, x² is the square of x, 3 squared is the square of 3. Then the middle term 6x is twice the product of x and 3. So this factors out as x plus 3 squared as a perfect square. Here is another one. What are we going to add to x² minus 11x to make it a perfect square? We can let the constant as usual be k. So that the expression can be written as x² minus 11x plus k. And this will be equivalent to a perfect square, say x minus a all squared, when factored as a perfect square. Minus was used there because we have a negative sign before the 11x. Now when we expand the right hand side, we are going to have on the left hand side x² minus 11x plus k, equivalent to the right hand side, which is x² minus 2ax plus a squared. Then comparing coefficients, the coefficient of x on both sides, negative 11 on the left hand side and negative 2a on the right hand side, definitely means that a is 11 over 2, as negative 11 over negative 2 gives 11 over 2, or 5.5, or 5.5. Then k, the constant term on the left hand side, is equal to a squared on the right hand side, the constant term on the right hand side, so that k is going to be 11 over 2 all squared, which is what we need to add to make the expression a perfect square. Or we can write it by taking the squares actually as 121 for 11 squared over 4 for 2 squared. It is time to generalize now from the two examples that we have taken. Looking at the first one, x² plus 6x, the constant added is 3 squared, which is 9. A look at this shows us first that a is 3, that's half of 6, the middle term, or the coefficient of x. Then we took the square of 3 in order to get the coefficient to add. So we added the square of half of 6. And when it does factor out, it's factored out as x plus 3 all squared. Plus, because the 6x is having a plus before it. Looking at the second one also, when we square the half of 11, we squared 11 over 2 to give 121 over 4. This also confirmed that we added the square of half of the coefficient of x, and this is going to factor out eventually as we have x squared minus 11x plus 11 over 2 squared. We factor out as x minus 11 over 2 all squared. The negative sign there shows that the middle term, the coefficient of x, is negative. Here is the result of our finding. Generally, the quantity to add is the square of half of the coefficient of x. Now let us apply this quickly to take a few more examples. 1. What must be added to x squared plus 5x to make it a perfect square? Now, without going through the process which we had to take for the first two examples, now that we know the result, we just first find half of the coefficient of x, half of 5. This is 5 over 2. Then we square the 5 over 2 to give us 5 over 2 all squared, or 25 over 4. So the quantity to add is 5 over 2 squared, or 25 over 4, meaning that the expression as a perfect square becomes x squared plus 5x plus 5 over 2 squared, or 24, or 25 over 4. And that we factor out as x plus 5 over 2 squared. Here is another one. What must be added to x squared minus 1.5 x to make it a perfect square? Now, x squared minus 1.5 x can first be written as x squared minus 3 over 2x. So the coefficient of x is 3 over 2. Then we find half of 3 over 2. Half of 3 over 2 is 3 over 4. Then we square it to give us 3 over 4 squared, or 9 over 16. So what to add to make it a perfect square is 3 over 4 squared, or 9 over 16, meaning that the expression becomes, as a perfect square, x squared minus 1.5 x plus 3 over 4 squared, which factors as x minus, because the coefficient of x is having a minus, x minus 3 over 4 all squared. Now that you know that what to add is the square of half of the coefficient of x, you can try these ones out. Send the solutions to us in the comment section, or forward them to the email address attached to the description of these videos. Don't forget to subscribe to this channel for more of our math tutorials, especially in our series of quadratic equations. We already have on the channel tutorials on all the factoring methods, including the slide and divide method. Once again, hit the subscribe button and click on the notification bell. Until our next math tutorial comes out, please stay tuned to our channel. Thank you.